Section 2.5 and 2.6 we're going to do together, and they're on congruent triangles. A triangle has 6 parts. There's 3 angles and 3 sides, and 2 triangles are considered congruent if you can match up their vertices so that all pairs of corresponding sides and all corresponding angles are equal. So in the triangles that we have here, we have triangle ABC, and we have triangle DEF. And if you notice, the markings on side AB and DE are the same. That indicates they have the same length. And the same thing with AC and DF, they have the same length. And BC and EF have 2 marks, 2 strokes on them, so that means they have the same length. And similarly, each of the angles, A and D match up, B and E match up, and C and F match up. So when all sides and all angles match up, you know that the triangles are congruent. They're basically the same triangle. If you cut one out, you put it right on top of the other one. They would be exactly the same. So when you write what's called a congruent statement, you need to match up those vertices in the proper order. So if I said triangle ABC, I would have to say is congruent to triangle DEF because A and D match up, B and E match up, C and F match up. So if I had to name the triangle, the first triangle, if I had to name the first triangle in the order BCA, then I'd have to list the vertices of the second triangle in the order B matches up with E, so E should be named first in the second triangle. C matches up with F, they both had the same markings on them, so that means they're both the same measure. And A matches with D. So there's a bunch of different ways you can write it, but you just got to make sure that the corresponding angles and sides match up. So the symbol for congruent is like an equal sign with like a sideways S on it, and it's red, is congruent to. Alright, so let's take a look at the first example here. If I have the congruent statement, triangle LMN congruent to triangle PQR, that means that angle L has to equal angle P, and angle M, which is the second angle listed in the first triangle, so that has to be equal to the second angle listed in the second triangle, which is Q, and angle N matches up with the last angle in the second triangle is R. And similarly, you can match the sides. L to M and PQ should have the same length, so LM equals PQ, the length of segment LM equals the length of segment PQ. And you also have M to N and Q to R will be the next side lengths that are the same length in the triangle, and the last one will be the first and last letter LN in the first triangle and PR in the second triangle. For the second example here, you would have angle D would match up with angle C, because that's the first letter named in both triangles. O is the second one, matches with A, the second one in the second triangle. And the last angle G matches with the last angle listed in the second triangle. And then you would have side DO, which is the first 2 letters of the first triangle, so that would match up with side CA. And OG, the last 2 letters in the first triangle, matches up with the last 2 letters in the second triangle. And the first and last letter DG matches up with first and last letter in the last triangle, which would be side CT. Okay, when you're proving triangles are congruent, you don't necessarily have to show that all 3 sides and all 3 angles match up. There are a few pieces of information that you can have that will be enough to show that the triangles will have to be congruent. Okay, one of these ways to prove that triangles are congruent is called side, 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 and basically just means you have to have all 3 sides matching up. If you have 3 sides of one triangle matching up with 3 sides of the other, then that's enough to show they're congruent. The other one is angle side angle, or ASA, and the way it's written kind of helps you remember it because the side has to be in between the 2 angles. So you get side in the middle with the 2 angles on the ends. So if you have an angle, a side and an angle matching up with an angle, a side and an angle in another triangle, then that's enough to show the triangles are congruent. And the last, next one, is side angle side. So basically, as the name suggests. If there's an angle in between two known sides that are matching up, then that's enough to show that triangles are congruent. And again, you would have to state the congruent statement matching up the correct vertices as they have there in the examples. And the last one you need to know is angle, angle, side. And this one, the angle, there's two angles and a side following it. Basically, the side is not in between the two angles. So if those pieces of information match up, so for example in the triangles that we have shown here, you have angle B is matching up with angle D, 68 degrees. You have angle C matching up with angle E, which is 76 degrees. And you have that side that occurs before angle B, A to B, and that matches up with the side F to D in the other triangle. So you have two angles and a side, but the side is not in between the two angles, so that would be AAS congruent. And your congruent statement here for this one would be triangle. If I said A, BC congruent to, you would have to name the first angle that would be named in the second triangle would have to be F, because A and F are the two angles that match up, and B is the 68-degree angle, so that matches up with D in the second triangle, and C is the 76-degree angle, which matches up with E. Now you could say that in a bunch of different ways, like it doesn't have to be that way. It could be, say for example, triangle BAC. And if I said BAC, the other one would have to be listed in the order. B matches with D, A matches with F, and C matches with E, and so on. So it doesn't, like I said, there's more than one way of stating it, so long as the angles and sides match up the way they correspond. Alright, so now we're going to try some examples of different types of proofs, and hopefully you'll learn as we do the examples what kinds of things to do. So my first suggestion to you when you're doing proofs is to write any given information that you have in your proof first. And given information would be information that's written. Sometimes in this particular case the given information is marked on your diagrams. Sometimes it's given in a given, like it's actually written down as a given statement, as you'll see in some of the later proofs. But this first one, the given information is marked on your diagram. So we're going to write those pieces of information down first. So SR is the same, is equal to ML, and you can do it as two separate statements or as one. I'm just going to do it as one statement here. And I have angle S, excuse me, angle S equal to angle M, and that's given. And oops, I have one more, sorry. And angle R equal to angle L. That's given as well. Alright, so I couldn't really fit it, I wrote too large there, but anyway, that's okay. So now I have, basically, I have enough information. I have ASA, two triangles that, both triangles have two angles with a side in between equal. So now I can state my congruent statement that triangle RST is congruent to triangle R matches with L, S matches with M, and T matches with N, and that would be angle, side, angle congruence. Okay, question number 2. This time we are given that in the diagram that PR is equal to SR, because they both have that same marking on them, so that's given. And we know that QR is equal to TR, that's given as well. And then we can, I'm going to just number these angles here 1 and 2, because otherwise I'd have to use 3 letters to name the angles, and I'm just trying to be a little bit more quicker writing stuff down. So angle 1 equals angle 2. That's because they're vertically opposite angles, which are equal. And then we have triangle. We've got enough information now because we got two sides and an angle in between those two sides equal to each other. So therefore triangle PRQ. If I name that triangle in that order, I have to name the other triangle. P matches up with S, R matches with R, and T matches with Q. And the reason for that would be SAS this time, because I've got two sides and the angle in between them. Okay, the next example has given AE and BD bisect each other at C. So that means that AC and EC would have to be the same, and DC and BC would have to be the same. Bisect each other means they cut each other in half, two equal halves. And we also know that AB equals ED. So this is the type of proof where they give the statements, they give the things you're given in a statement, and you have to mark them yourself on the diagram. It helps to mark them on the diagram so you can see what kind of information you have. So I'm just going to write the given statements down first, that AE and BD bisect. No, I don't have enough room there, so I'm just going to say bisect at C. And that's given. And the second statement that's given is AB equals ED. So from the first statement that AE and BD bisect each other, I know that AC has to equal EC. Whoops, I forgot to write down that was given, the second statement. So I know that AC equals EC, and by the same reasoning, DC equals BC, or BC equals DC, because definition of what it means to bisect. So just say DEF apostrophe N for definition of bisect. And then we also have, we can mark in as well that we were given that A, B, and ED were equal to each other. So now we have two triangles equal to each other. They're congruent, I'm sorry, because of SSS information. So triangle ABC is congruent to triangle A matches up with E, B matches with D, and C matches with C, and that is SSS. And therefore, this time we're not finished now because we had to prove that angle A equals angle E. But because we've proven that the triangles are congruent, A and E are corresponding angles in the triangle, meaning they're angles that match up with each other. A has to equal angle E because of they are corresponding parts of congruent triangles. So corresponding parts of congruent triangles are congruent. Now, when I was in school, we used to abbreviate that as C, P, C for congruent, T for triangle, C for congruent. So C, P, C, T, C. So if you don't want to write all that out and you want to write C, P, C, T, C, I'll know what you mean. Okay, so the next example, you're given that LT bisects angle PLN and PTL equals angle NTL. So I'm going to write those given statements down first. So LT bisects angle PLN given, and angle PTL is equal to angle NTL, and that's also given. going to mark that in just so you can see a little better. So PTL equals NTL, and because LT bisects angle PLN, here's P to L to N, that means that these two angles, angle 1 and angle 2, have to be equal to each other because of what definition of bisect an angle. Right? When you bisect an angle, it cuts the angle into two equal parts. So angle 1 would have to be equal to angle 2. So now we have two angles matching up in the triangles. So we'd have to look for a side now, and the side that is matching up in both of them is the common side that they both share. LT equals LT. That's common side. So that means I have triangle LTP now would have to be congruent to triangle LT to N because of two angles and then a side in between those two angles, so to be angle, side, angle. And then from that, LP matches up with LN. So LP has to be equal to LN because they're corresponding parts of congruent triangles are congruent. Hope that didn't frighten you too much. That's my dogs. One of my dogs. The other one's going to start barking now too. But it's hard to get a lot of time when I'm not barking. Okay, so the next example given, triangle ADC is an isosceles triangle, and B is the midpoint of AC. You have to prove that ABD is congruent to CBD. So I'm going to write the given statements down again first. So triangle ADC is isosceles triangle, given, and B is midpoint, whoops, I'm just abbreviating a little bit. B is midpoint of AC, and that's given. So from that, if triangle A to D to C is isosceles, that means two sides are equal. So if we look at the triangle, it looks like AD and BC are the equal, and DC are the equal sides. So AD would have to be equal to DC. It should be a little bit more obvious than that, but so that's definition DEF apostrophe N, just to abbreviate for definition of isosceles triangle. And then we have that B is the midpoint of AC, so that tells us that AB has to equal CB because of definition of midpoint. Midpoint means it's in the middle of the segment, which means it's going to cut it into two equal parts as well. So AB and BC would be the same length. So now I'm going to put a little mark there so I know that those two are equal. And then I also have that BD has to equal BD because of a common side. So now I have three sides matching up in the triangle. So therefore, in the triangles, so therefore triangle ABD, if I name the first one that way, I have to name the second one CBD by SSS. So, because all three sides match up. And that's it. That's all you had to prove in that one. Okay, the next example says given AC equals BC and angle 1 equals angle 2, prove that angle A equals angle B. So we're going to write our given statements down first. Whoops. AC equals BC, given. And angle 1 equals angle 2, given. And then you should mark them off in your diagram. So angle 1 and angle 2 are equal, and AC equals BC. So now, in order to prove that angle A equals angle B, they're parts of a triangle. So we'd like to prove the triangles are congruent first, and then those angles A and B should be corresponding parts of congruent triangles. So if you look at the diagram, you've got a side and an angle in both triangles, and they both share this common side CD. So that would be our next statement, CD equals CD. Looks like a P, I gotta fix that. CD equals CD, common side. And then that means we've got side angle side congruence there. So triangles A, CD would be congruent to triangle B, CD because of side angle side. You got two sides and the angle in between those two sides equal to each other. So therefore, if the triangles are congruent, then A and B are matching parts, so angle A would have to equal angle B because corresponding parts of congruent triangles are congruent. Or you can use the CPCTC acronym, I guess it would be called. Alright, so those are some examples of proofs, and there's some questions there in the book that you can try on page 106 and 113 to 115. And in question 3, just notice there on page 106, you just need to write the congruent statement. Don't follow the rest of the instructions. Okay, and that's it for that chapter.